Welcome to Soil Mechanics. We are going to do what we call a permeability test. That is the falling head permeability test. And for this test, what we require are the following apparatus. We require, first of all, the stand, which is this one. This is the stand. We require a meter rule, which is this. We require a burette. We require a standard mold, which is this one. And we also require a gasket, which we will be able to put at the top so that when we tighten, we will be able to ensure that we don't have water coming out from the top. We'll also be required to have a spatula or a straight edge, which will be able now to get our readings from that ruler. Apart from that, also the spatula will be able also to use in trimming the soil sample from our mold. We'll also be required to have a wash bottle. We are also supposed to have a vernier caliper to be able to get our measurements, adjustable spanner to be able to tighten the screws on that mold. And also we are supposed to have a gravel, which is this one. We are also supposed to have a stopwatch. This is our stopwatch. And before you do the falling head, you must first of all start with a compaction test. Compaction test will enable you to be able to get MDD, that's the maximum dry density of that soil sample, and also the optimum moisture content of the soil sample. When you get those two values, you can now be able to calculate the amount of soil sample that will fill the standard mold for purposes of having that test. We are also supposed to calculate the amount of water which will be used to be able to mix that calculated soil sample. So you need to first of all do a compaction test so that you are able to get those two values, because without those two values you cannot be able to determine exactly the amount of soil sample and also the amount of water required to be able to mix with that soil sample. So the preparation of this test, you need to first of all start with that compaction. Then after that, you need to soak that soil sample, which will be now be placed inside this mold for 4 days. When you soak it for 4 days, after 4 days, now you can now be able to remove from this that water tank and be able now to run the test. So I have a sample which I have already soaked. So I'm going to bring my soil sample from the tank where I've soaked so that I'm able to run the test. And I will have to place it here so that I do some preparation before now running the test. So I will trim the soil sample from the bottom of that mold so that I create space where I'm going to place gravel. So just approximate like about 5 millimeters like that. Then on the other side also I'll have to trim. So I'm going to get the depth that I've trimmed. By using this vernier caliper, I can be able to measure. So I'm going to use this straight edge and be able now to get how much I've trimmed. So I have to get at least 4 points. So the first one is this 4.5 millimeters. Seven millimeters. Six millimeters. Five millimeters. So when I have to record those values, that is 4 millimeters, 4.5 millimeters, we had a 7.0, 5.0, and then 6 millimeters. So I have to get the average of that by adding and then dividing by 4. From there now, I can be able now to tell how much I've trimmed at the bottom. So after doing that, the next thing is that I will have to put gravel. Then using this wash bottle, I need to add a little water on that gravel to be able to wet it, just like that. And then at the top again, I will have to also get the measurements. That is how much I've trimmed at the top. This is 2.5. $6.5. $3.5. And then the last reading should be, let's say, taken at this point here. This is 5.5. So you again take average of those 4 data, and then you get now the value of the depth that you have trimmed. So after working that, you need now to again add or put gravel at the top, just a little of that, and spread it. And then you again add water. And then we now place this gasket at the top, just like that. And then now we bring this thing at the top to be able now to close or just like that. And then now we have the screws now to be able to hold this cover, which is placed at the top. So I'm going to tighten these screws. So now when it is tight, then I will now have to place it at this position and be able now to connect my burette just like that. So I need to wipe out any water which is on the surface, so that when I run the test, I can be able to see if there's any leakage from the top here, because we only expect to have outlet from the bottom of this mold. So this is where we only want our water to come out from. So at no other point should we see any leakage. So I need to wipe this position so that when I do the setting up of this thing, I should be able to notice that if there's any leakage. For me to be able to check that, I'll just open this point here to be able to allow the water to flow. As you can see, there's some water coming out from that point, so I need to tighten it a bit so that we only have water exiting at the bottom. Right now it is it's not leaking at the top. So when it is not leaking now, you can now be able to run the test. So after ensuring that the sample is set up, then I will be required now to fill the burette with water. So I'm filling the burette with water. Up to the brim, like that. Before you run the test, you need to determine what is the height of water in that burette. So I'm using this straight edge to be able to get what is my initial reading, that is H at 0 minutes. So using this straight edge, I'm able to get my initial height as 96.2. That is the head of water in the burette is 96.2. When I open this point here, I'll be taking readings at a certain intervals. So I can decide to take readings at intervals of, let's say, 1 minute. That is, if it is 1 minute, that is going to be 1 minute, 2, 3, 4, all the way like that. If it is, let's say, intervals of 2 minutes, then it's going to be 2, 4, 6, all the way like that until you get about 5 readings. Then you stop at that particular point. So before starting the stopwatch, I'll first of all have to open this point here so that just allow the water to first of all flow before now starting. So when everything is set and you have ensured that there is no leakage, then I'll again have to top it up. Now that I've known that my height at 0 time is 96.2, I will now have to get, let's say if I'm working with an interval of 1 minute, I will now be able, after 1 minute now, I'll check what is my H after 1 minute. After 2 minutes, I will also check what is my H. So when I get about 5 readings, I can stop with that. And with those values, I can now be able to calculate the coefficient of permeability of the fine grained soil sample. So I'm starting the stopwatch. I'm using an interval of 1 minute. It's now 1 minute, so I can now be able now to get the reading. It's 96.0. So I'm again supposed to get a reading. That is a 95.3. 95.3 after 2 minutes. Three minutes. $94.6. The fourth minute, we have a reading of that is 94.2. So you continue all the way like that until you get, let's say, about 5 readings. With those values now, you can now be able to use those data to be able to calculate the coefficient of permeability of the fine-grained soil sample. So this setup is used to be able to determine the coefficient of permeability of fine-grained soil samples.